How many of you are absolutely terrified of Linux? Like, whenever somebody's talking about Linux, it's just like you're just like shut down. You're like, what the hell? Like, this is scary, scary, scary stuff. We got people that love Linux, right? Awesome, awesome. We got people that love Linux. We got people that have never used it. We got people that are scared of Linux for very good reasons. Here, let me give you an example. All right, we're going to do some questions, everybody. What's your favorite Linux distribution? Just kind of jump in. What is the favorite Linux distribution? Debian, we got Kali, we got Ubuntu, we got Parrot. There we go. Gentoo, Fedora. More Debian, Arch. There we go. Lots and lots of good ones. Ubuntu no Mint. I love that too. Awesome. Slingshot. There we go. Yep. The old Sans 504 Slingshot distribution in the house. That's great. All right. Mint is for kids. Kali is for me. Oh my God. See? Now, next question. What is your favorite command line text editor on Linux? Everyone, what is it? What is it? Linux people? We've got Vim, we've got Nano, we've got Vim, we've got Nano, no Kate. No, so we got Sublime. That's in there. Awesome. Sudo. You know someone's a real badass when they're like, dude, I just use sed knock as a stream processor, a direct file. And you're like, whoo, wow, that guy didn't date in high school at all. So when we're going through all of this, for those of you that are a little bit terrified about Linux, right? How many of you feel better about Linux? Like, we're talking about all that. Do you feel better? Like all those Linux distributions, all these arguments about text editors, all of these different, is it just like, oh my God? Yeah, no. Yeah, not feeling better. See, they're still arguing over Vim and Nano, right? And they will argue over that crap. Like Linux people will argue over that crap for decades, right? Just, it's like a thing. They fight about it. And then they get together at when they're fighting over all their distributions, when they're fighting over, like what text editor to use, or another one, GNOME or KDE or like Cosmic. What is your desktop? What is your desktop environment? Are you using Enlightenment? Are you using a tiling one? We got Hyperland, we got Sway. No desktop. Yeah, I don't know how they're here, but no desktop. XFCE. Yep, yep. All of this for people that are new to Linux is terrifying as hell. Seriously, it's just absolutely scary, scary stuff. There's nothing about this that screams user friendly at all, like whatsoever. And all the Linux people get together and like, I don't understand. How come we don't have more people using Linux? And then there'll be someone in the corner that says, I installed Ubuntu. And the other Linux people are like, screw you. You should be using Gentoo and compiling all of your binaries from source at runtime. And the people that are just getting started are like, I'm going over here back to the Windows and Mac people because they just want their computers to work, right? All right. So what we're going to do is I'm going to get you introduced to Linux, and we're going to take all of that crap. We're going to throw it away, right? Because the things that I'm going to teach you on how to use Linux and how to use Linux to detect malware and the commands that you should use and how it works, they work in all of those stupid distributions, right? It doesn't matter. There's no political or religious allegiance to different distributions out there. Because whenever we're talking about Linux, eventually some BSD dude or dudette is going to jump into the chat and then they're going to be like, oh, we should be using BSD because it's not been corrupted like Linux has over the past few years. It's like, oh my God. All right. So this is going to be a gentle, caring, nice introduction to Linux. And literally all of these things that we're going to discuss are going to be applicable to all the various distributions of Linux. Okay. Because if you want to learn Linux, seriously, if you want to learn Linux, don't go out and try to learn Linux distributions, learn Bash. Like anything you can do, like Code Academy and understanding Bash shell and all of these things, learn Bash. Now, whenever we talk about Bash, oh man, that is not what I wanted to do. But I just I really sent that in there. Oh, that's crazy. If you're trying to learn regular expressions, you need to go to Joff Thayer's Regular Expressions, Your New Lifestyle class. We have a class. It's awesome. It's by Joff. You're going to be a regex master. Over the Wire, great as well from HK, but you need to learn Bash. And the reason why you need to learn Bash is all of these Linux distributions, okay? I'm just going to throw this out there. All these Linux distributions get really, really worked up. And seriously, the only difference is the way that they skin their desktop environment and their package management, honestly. Now, I know that there's more differences. I know that people get freaked out over that. But if you know how to use Bash, you're going to be able to use Kali, you're going to be able to use Ubuntu, you're going to be able to use Parrot, you're going to be able to use SUSE, you're going to be able to use all these different Linux distributions. You're going to be able to use BSD, you're going to be able to run Solaris, you're going to be able to run HPUX. All of these things are now your oyster because you have learned Bash. And Bash is magic. Now, every once in a while, you're going to have somebody that comes in and they're going to say, yeah, Bash is okay, but you should be using Z shell or K shell. Don't party with those people. Don't date those people. We don't want those people procreating because if they continue to produce other little people that get mad about what shell that other people are using, it's just going to continue the paradigm of evil just continuing to go through. So learn Bash. These other shells have their advantages. Learn Bash first. All right. Those people don't party or date. Hey now. All right. So we jump in. So whenever you're talking about Linux and Unix, we have a lot of people in the world that like to say things like, I think Windows is easy and Linux is hard. And if you're ever walking around and you're saying things like Windows is easy and Linux is hard, proves two things about you. The first thing it proves about you is you don't know very much about Linux, and that's okay. But the really scary thing is it actually proves you know nothing about Windows either. Because if somebody is really good at Windows and you say, well, Windows is easier than Linux, most of the time they light a cigarette, they take a hit from a bong, do a line of Coke, and they say, no, you are very wrong. You are very wrong. Windows is a nightmare. And that's from Windows aficionados that know the Windows operating system because it's wow, it's very, very crazy working in a Windows environment. And really the reason why people like Windows more than Linux is one simple reason, a GUI. That's it. It's just the GUI. It did escalate quickly. It did escalate quickly, Ron Burgundy. That is true. All right, so we're going to go through and we're going to play around with the file system on Linux. All right, we're going to get started with playing the game of where the hell are things on Linux. Now, to do that, I'm going to jump over to my Cloud Labs and I'm going to start my labs. I'm starting both of them at the exact same time because I'm cool like that. Yeah, I'm not going to start one and then the other. No, 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 no. I'm going to start all machines and I'm going to rock out with all my machines ready to go. Pew, 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 pew. All right. So my machines are starting up. You can play along if you would like, but we're going to go through, we're going to do this slow, we're going to work together, and it's going to be awesome. It's going to be fun because Linux is my favorite operating system. Now, some of you will look at me and say, oh, but you're using a Mac. No, the only reason why I'm using a Mac is because of the video and audio that comes default. And MacBook Airs and MacBook Pros are amazing for travel, and I travel a lot. So having something that has a really high resolution camera and has a great microphone, and I can use it anywhere, and I can adjust the lighting and do everything I need, like on the fly, chef's kiss, chef's kiss. And on Linux, it's a crapshoot. Trying to get those things up and running, and I don't want to carry around a microphone and two turntables because who is going to carry around two turntables and a microphone with their computer? They're just not. So whenever we're looking at Linux, we're going to start by looking at the file system structure, and I'm going to go through the file system structure on your Kali system as soon as it comes up, because learning where things exist is really, really, really important for you to be comfortable within an operating system. Like, where are the different files? How does it break things up? But before we get into that, let's talk a little bit about Windows and kind of do some pros and cons and contrasts, right? So where does Windows store configurations for applications and services? So if you download a service, where is Windows going to install the config for that? App data, possibly. Could be app data, could be registry. Where else? Yeah, it could be alternate data streams, right? System 32, right? Could be all of these roaming app data that doesn't display by default in Windows Explorer. You have to go in and change that. Could be in the directory that for the program files x86. All of these different places are places where Windows can put configuration data and also binaries. It is very, very difficult on Windows systems to try to figure out where stuff is. One of those examples would be like Steam. If you're running Steam as a video game machine on a Windows computer system, it can put it in the Steam directory, it can put it in program files directory, it can put it in app data, it can put it in app data roaming, it can put all of this data all over the place, and it can become very difficult from a unified perspective to understand where the binaries are, where the configurations are, and all the different things that make it work. Whereas when we jump into our Linux system, which we're going to do just now, you're going to see that it's a lot better. It's going to be a little bit cleaner as far as where binaries and config data reside on a Linux computer system, because there's going to be a lot more consistency on where these things reside. So we're starting up our VM. Open up Kali. I got a question. Did any of you know people with the name Kali? Like, we had an employee, an intern, her name was Kali. She was awesome. And I've got a friend whose name is Kali. And it's always weird, like in this space, when you run into somebody with the name Kali. Like, computer security nerds are just like, "Oh my God, your name is Kali. There's this hacking distribution that's named Kali as well, and it's really, really," and it's just like, they are not interested. It's just not something that they consider to be interesting. So don't do that to people named Kali, because they don't like it, right? So let's jump in. So I'm going to start at the very beginning. We're going to go cd space /. Whenever we do cd space /, that means we're moving to the top of the directory structure on the Linux computer system, right? So now if I type ls, you can see I have my intro labs, I have my bin, my boot, my dev, my Etsy, my home, my lib, 32, 64, lost and found, media. I'm going to get to media. There's going to be a rant about media. Just stick with me. Opt, proc, root, run, snap, sys, user, var, all kinds of fun things, right? So let's go through these different directories, and I'm going to talk about what's in these directories. So intro labs is the directory that I created that has the tools that we use for this class. That's what's there. Now I'm going to cd into the bin directory. So we're going to go cd into bin. What is the bin directory? What does it do? Let me go backwards. There we go. The bin directory is where binaries reside. All right, that's where binaries exist, right? So if we're looking, I have a binary called zip. I've got another binary called yes. I've got xspy. I've got xhydra. I've got xfe. I have all kinds of binaries that exist, but these are where the binaries themselves reside. So let me run this a different way. I can do ls just to list them like that. I can do ls-lrt and change the way it's just going to be displayed. So when I'm looking at the bin directory, we're going to have binaries. They store the bin binaries. And that's actually really cool, right? So if you're ever looking for binaries and you want to learn Linux and you want to figure out what these different things are, you can come in and you can do like man nc, and it'll give you the man pages for the netcat command on your Kali system. It'll say, here's a little user guide for this particular program, which is pretty cool. All right. By the way, I'm clearing my terminal. You can see me typing stuff and doing stuff. And whenever I'm clearing my terminal, I'm just hitting Control and L, and it clears all the garbage. There's just some cool tricks you learn. Just Control and L will clean that stuff up. Let's go into boot. So if I cd to the top level and I go boot, like so, these are the different images that exist for the kernel on the operating system. So we got system map version 6.6.15 cloud, 6.6.9 config. We got EFI and grub for boot managers, which is something that you can run in a Kali distribution. And then we have our actual VM lins, which is our kernel version for the operating system as well. Now, what is this? So whenever you update your Linux kernel, okay, it updates in grub and EFI the pointer to which of the kernel versions is going to be used. It keeps that previous kernel version around. Does anyone like want to know why Linux and Unix would keep the previous kernel version around? Why would they do that? Anyone? Yep, recovery and rollbacks, right? And the kernel itself is actually really, really super small. Getting into a wee bit of history, a long time back in the day, like we're talking 60s, back when they were developing the OSI model before networking existed, there was a huge argument as to whether or not we wanted monolithic kernels or we wanted microkernels. So a monolithic kernel would be a kernel that the entire operating system is the specific use operating system that is designed for a specific purpose. So if I'm doing an inventory, there would be a computer system that would be created that just does inventory management. And that's all that it does. That's it. Now, back in the 60s, don't trigger me, Nerf, don't. Back in the 60s, how many computers did they think the world needed? Oh my God, Fuzz. Sorry. Fuzz, I'm making a shirt of that. Hold on. Hold on. We got to stop everything. RM-F OSI model. I'm putting that in right now. It's going to happen. Get a hold of Yuri and we'll get your address. And when we get it, we'll get you the first one. I'm typing it in. I'm typing in the email right now to my team. We're doing this. We're doing this. Sending it out now. There we go. All right. That's fantastic. That's why I do this class, right? That's why I do this class, because I learn new things, right? So, and that's a great idea. Get great ideas from students. It's amazing. It's amazing. So thank you very much. We'll get that set up. All right. So back in the day, there was arguments of whether or not we wanted monolithic or the microkernel, right? So the idea of a monolithic kernel was the computer was the operating system, was the application. And they were basically saying, hey, you know what we need? We need like 6 computers in the entire world. That's it. So the monolithic kernel idea made sense. However, microkernels won. And the idea of a microkernel is a very, very, very small kernel that you can add modules dynamically to. Now, part of the argument was if we went with a monolithic kernel, there would be fewer security issues, there would be fewer bugs, there would be fewer problems because it was literally just one unit. You would test it, make sure it would work. Getting into the late 70s, early 80s, we get into the TSIC Orange Book series. See, Brian, I was alive in the 80s. And you know, when I was 6 years old, having conversations about the Rainbow series and Orange Book and free after use memory security control considerations, yeah, all that stuff. That was what I was doing when I was rolling around on a trike, thinking about those things, right? So the microkernel won. All right, the microkernel one. So when you're looking at these kernel sizes, they're really not that big at all. Like they're just not. You're looking at very, very, very small files that run the kernel itself. All right, so what's the next one we got? We got device files. This one's awesome. This is one of my favorites. I'm going to say that a lot today. I'm going to be like, oh wow, there's a lot of my favorites here. So everything in Linux and Unix is a file. All right. Everything in Linux and Unix is a file. A directory is a certain type of file. You have your keyboard is referenced as an input file. You have your display as a file. Standard in, standard out is a file. And even me typing in the command prompt, I'm typing in something called a teletype terminal. So if I type TTY, it comes back and it says, you're currently typing in a device file called devpts0. So that is my terminal. That is referenced as a file. And this actually makes sense because if you have everything that looks in the Linux computer system as a file, there's different types of files, and those different files will be handled differently. You're literally just looking at inodes and you're looking at positions on how to actually tell the operating system to receive and transmit data to these different locations. Can be a directory, can be a file, can be the output, can be dev null, nothing. There's a joke out there that everything you send to dev null gets sent to Redmond. I think that that's kind of funny as well. But these are all files that exist on the operating system, right? So we have things as far as what the display is. We have the memory, which is going to be referenced in something a little bit different. There's even things like random. You see this random file? I can do cat. Let's do dev. And let's do u random, like so. Now check this out. All of a sudden now my computer is getting really weird. Okay. That's very, very strange. What is my computer doing? Just printing random gibberish. That's all it's doing. Just doing gibberish, right? Now, why would your computer system, your operating system, have this feature that just prints random gibberish. Why would it do that? First screensaver, love it, love it, love it, love it. Crypto? Yep, absolutely. So whenever you're dealing with crypto, you're working with TLS, SSL, you're working with internal encryption, working with these things, there's a lot of randomness that is used to generate seeds and generate keys. All right. So one of the things that you can have is you can have a salt in a file, like let's say Etsy Shadow, where your password hashes are stored, where it salts in randomness with your password to make it more difficult to crack that password as well. Deb, I don't know if we have some pictures of some Rock'em Sock'em socks that we have coming up, which is one of my favorite projects that we're working on. But let me give you like a useful incarnation of how to use this, right? So I had this, he wasn't a boss, but he was a manager. He was the network team manager. I was on the security as a tech. And he like farted constantly. Like he always said that he had some type of gastrointestinal issue, and he may have had a gastrointestinal issue. I'm not sure. But he would basically come into meetings and he would just fart constantly. And he loved coming into my office and just sitting in there and trying to talk to me and just like sit there and be like, "Oh wow, did you watch that game? How would you like to talk about politics and religion, John?" And he would just rip ass in my office, just psh, loud and proud, which by the way, part of me respects that. Part of me respects that, right? So I always kept this up on one of the screens where I just have dev u random, just like just blowing stuff out, like pun intended. And he would come into my office and he would sit and he would talk to me for a little bit. And then all of a sudden I'd look at the screen with dev u random and I would go, oh, look what's on my screen right now. Oh my, hey, I gotta get this. I gotta get this, Bill. I am so, oh my God. Hey, Bill, I'll catch you later. And he would just look at me and just be like, look at my screen. He'd be seeing this gibberish and he would go and tell everyone, he's like, John's like an amazing hacker. He's like watching The Wire real time, watching for hacks as they're coming in. So it was a great way to get bosses out of my office. So that was a lot of fun. One of the problems with catting dev u random, there we go. Stop, is getting it back. I think I broke putty. That's awesome. All right. So we'll go back into a brand new terminal, get that set up. Let me go into the way it looks. So there you go. You can see that I actually have a file that just does nothing but generate randomness. So the takeaway for that is just to understand that everything in Linux and Unix is a file. And when you start looking at it from that perspective, the file exists in the operating system somewhere and we can hunt that down. Etsy. Now, this is where it gets once again, one of my favorite directories because I think of such things. I asked you earlier, where does Microsoft put configuration files for different applications, right? And the number of you said the registry, it could be in user data, it could be in roaming, it could be in the System32 directory, it could be in the cloud. Hell, you don't know. It could be in various JSON files and alternate data streams behind other files. That's all kinds of crazy stuff and where it could be. And all of that is true. Generally, on Linux and Unix systems, anytime you're looking for configuration of a service, of an executable, of a file, it's going to be in the etc. directory, etc., etc., etc. And this is the Etsy directory. So when you're looking at all my configurations, I have my host configuration for DNS information. I have my configuration for OpenVAS. I have my configuration for passive operating system fingerprinting for pluggable authentication modules. I have my password file. I can look at this. This is kind of crazy. So this is going to kind of freak some people out. I have the password file on a Unix system. It's configuration for the operating system. What's not in the password file? What's not in the password file on Unix and Linux-based systems? What's not in here? Yeah, there's no passwords. Why? What the hell? What happened? All right. Has anybody here read Clifford Stoll's The Cuckoo's Egg? Anyone ever read that? All right. So in The Cuckoo's Egg, Clifford Stoll sees the hackers going into the computer system and they're copying off the Etsy password file. Now, this book was written in the 80s, right? And back in the 80s, the password hash was actually stored in the password file. It used to be stored right in this file. In fact, everywhere where you see this X, like you can say UCC, UUCP, proxy, WW data, where that X is, that is where you can put a password hash for that particular account. All right. So that is where it exists, nobody, and so on. So all of these files no longer have the password hash stored because this file is readable by everybody on the computer. And they learned in the 80s that an attacker can just pull down this file and crack the passwords. It was the 80s. They didn't quite understand how hacking worked, but that's a really cool thing that you learn in the Cuckoo's Egg. So instead, what they do is they put it inside of this tool called, or this file called Shadow. Oops, that was stupid. Let's do cat shadow. Oh, I gotta become root. Hold on. Fix that in a jiffy. Here we go. So in the shadow file, if I get at the bottom, you can actually see the password hash for Kali is stored right here, right? So there is the password hash. And as you just saw, it's only readable by root. I had to become root to be able to see the shadow file on this particular computer system, right? Now we have a bunch of accounts where there is no password hash stored. What does that mean? Can you just log into all of these accounts with no password? What does that mean? Yeah, it means it's service accounts. Either A, you cannot log into those accounts, or B, they're accounts that you have to sudo into, like root. I can become root, but I have to sudo into root. All right, there we go. So once again, that's configuration stuff. That's going to be in the etc. directory. Now, the home directory is the directory for all of the users and where they put their files. So this would be like your documents directory or your user directory on a Windows computer system. So I can cd into Kali, and you can see a bunch of files in here, right? I can see desktop, documents, downloads, music, pictures, public, templates, videos. Netcat is present, files.tar, volatility, sam.txt, snap manager, which is another version of a package manager. And these are the files that exist in my home directory. Some of them are executables, some of them are not. The blue ones are directories. The color will actually change based on your distribution and your terminal configuration. Now, this is cool, right? These are the home files for each of the users that exist on this computer for like things like downloads and documents. But there's also configuration files here. If I do ls minus a, you can see a whole bunch of dot files. See that there's a difference between these different sets of files. I have files like SAM, or files, or videos, or downloads, or music. But then I have a bunch of files like bashrc, cache, config, dbus, gdb, init, GNUPG, which is for PGP, Java local Mozilla, and Metasploit, MSF4. Notice that all of those files start with a dot. They all begin with a period. The reason why those don't show up when I do a standard ls and they show up with the minus a is the minus a tells me to show the files that are hidden. Now, hidden does not mean malicious files. Just because they're hidden doesn't mean it's malicious at all. It just means that they're files I don't want to see. They're configuration files for a bunch of different things that I don't want to see and work with, but I want them to be there and I want to configure and work with them specifically as they exist within my Linux computer system to configure my experience on that system. But I don't want to see them. It's kind of like the hood of a car. I want an engine to be in my car. I want it to be present. I want to be able to change my oil. I want to be able to change my washer fluid, transmission fluid, DEF fluid, all of those different things. But I don't want to see it all the time. So they put a nice little hood over the front of it. Unless, of course, you're dealing with Mad Max, at which point they want that stuff displayed all the time with flamethrowers and guitar players and loudspeakers. That's awesome. So you can see how this displays things differently. We can see it with the hood closed. I don't want to see all the configs, or we can see it with the hood open, where we can see everything as well. Now let's talk about lib. This has nothing to do with politics at all, right? We have people that are like, lib, is that where the libs are? Is this where you own the libs on your Linux computer system, you lib? No, nothing to do with politics. Lib stands for library. All right. Lib stands for library. So if I go into the lib directory, let me go to the top level directory first and type ls. You can see I have lib, lib32, and lib64. I have libraries. I have 32-bit libraries. I have 64-bit libraries. So if I go into lib, like so, you can see all of the different libraries that are required for this operating system to function. So I talked about a microkernel architecture, right? On a Linux-based system, you're going to have this microkernel architecture where you have a very small kernel, and then as it needs additional functionality like copy and paste, accessing networks, accessing tools like BetterCap, it's going to reach into these libraries or these shared object libraries, and it's going to pull out the functionality that's required, and it's going to snap it into that kernel, and it's all of a sudden going to develop the skills of that kernel. It's kind of like Voltron, right? You can basically have a very, very small black, like Voltron tiger, and then, or lion rather, and then you can bring in the other ones and you can make Voltron bigger and stronger. So that's what you're doing. You're grabbing these libraries of functionality and you're pulling that directly into your kernel. But these are all the libraries that can be used to update the kernel itself. All right. Does that make sense to everybody? So far, are we doing okay? I know a lot of this stuff is like watching like paint dry, but I'm trying to make it a little bit more interesting. I just want to make sure that everyone's good. We're developing a better, richer understanding for the ecosystem of a Linux computer system. All right, media. God damn it. Okay, there's another $5. Okay. Deep breaths. Media. All right. So, what would it take? Like, what are the things that are holding you back from using Linux as a daily driver? Like, seriously, some of you have never used it before, and I think that that's a valid answer. We got some people, nothing. Yeah, I know. I get charged five. No, I'm going to pay $5 every time I swear to the EFF at the end of this year. Proprietary software overloads. What is the software that you want? Gaming. By the way, Steam OS, holy crap. Not a swear word. They are absolutely crushing it. Like Steam is crushing it for video games. Compatibility for Microsoft Office. Excellent. What else? What other applications? Office and Adobe, right? That's the big thing that's holding people back. Now, here's the problem with the Linux computer community, right? It's weird. They occupy this space that's not conservative or liberal. They're just weird in their own right. And whenever they're looking at people using Linux, they do the dumbest things, right? Like one of the dumb things they do is instead of making OpenOffice or LibreOffice completely compatible with Microsoft Word and Microsoft Excel docs, they try to come up with their own proprietary format that's an open format that everyone can use. That Microsoft is basically like, screw you. I'm not even going to open those formats, guaranteeing that no one is going to use those formats. But that is the hill they're going to die on, right? So rather than saying, hey, let's make LibreOffice completely compatible with Microsoft Word or Excel, they're like, nah, let's come up with a new standard. Cue the XKCD comic, which someone is going to post here shortly as well. So that sucks. The other thing that happens with Linux and Unix based people is they're like, you know what's keeping people from using Linux? Mounting. Like when they plug in a USB drive or they plug in, like, say, a floppy back in the day and all these different things, trying to mount things is really, really difficult. So instead of mounting it in Mount where God intended it to be, they created the media directory. So now when you plug in a USB drive, it mounts it to media. And in some distributions, they don't even do mount to media. They mount to CD-ROM or USB 0, USB 1. These are the things that they did to try to make things better, to try to make people use the operating system more. So like, yeah, once we name it media or USB, that's really going to bring in the kids to use the operating system. So I hate this. Because the way it should be is everything should go to mount, right? So if you look in the mount directory, everything should be mounted in the mount directory. So I have a lab where you actually set up a Windows share on the system with the mount directory. It's a completely different lab. We're probably going to get to it a little bit later when we're working with malware. But the point is, that's where God intended us to put things, was in the mount directory, like mount USB, mount CD-ROM, mount whatever. So that's where it should be. But they try to do media, they try to do USB. See, and that's another problem, guy. They all do it and they do it differently, right? They do it differently, and that's creating more and more frustration. All right. So the opt directory, if I go into the opt directory, And the opt directory is for programs that are completely self-contained. They're programs that are going to have their configuration, they're going to have their binary, they're going to have everything all tied together in one nice, neat little package. So if I cd into John the Ripper, which is a password cracker, I have the docs, I have the run, and I have the source code, right? So if I go into run, this is where the binaries exist for John the Ripper, right? So that's what's in this directory. If I back up and I go into source, let's go to opt John and then source SRC. This is where the source code for John the Ripper resides. It's completely self-contained. So generally with like programs that load an opt, that's where it resides. All right. So it's all contained in one package. Now, Kali and the Debian way, they tried to kind of break with that a little bit. And they wanted people to use it the Debian way, where the binaries go to bin and the configs go to etc. So it's completely accessible by the entire operating system. But that's just kind of wasn't in the cards. There's still people that use opt. Proc is super cool. Let me show you proc. Let's go proc. So in the proc directory, you see all these numbers: 16, 1595, 1582, 1580. Those numbers represent process IDs. They represent process IDs. Now, we got to spend a little bit of time and we got to talk about process IDs and device IDs, right? So when we're talking about process IDs, are process IDs handed out sequentially? That means if a process ID is higher, is it always a newer process than a lower process ID? No, it's not. It kind of looks that way when it starts, but as it reuses the process IDs, it's going through and it's going to grab the random process IDs. So don't ever look at process IDs in terms of like, well, this one's like 268, therefore it's going to be an older process than 269. That's true on Windows and it's true on Linux, that it'll be random. So don't always look at these as like a lower process ID as an older process. All right. So that's really, really super cool. And if I go into any of these directories, let's go to 1171, like so. It's going to give me like, what are the attributes for this process? What are the attributes and network connections associated with it? It's going to give me the task. It's going to give me the executable directly that I can use as well, which is super, super cool. So let me kind of show you a little bit. And this is going to be a lab that we're going to do here in a moment. I'm going to set that there. We're going to open up another Kali terminal. And I'm going to open up another Kali terminal. Let's do two. All right. So I'm going to set up a listener here. I'm going to go netcat listen on port 2222. And then I'm going to connect to it netcat 127.0.0.1 on port 2222. Now I'm connected. Now, let's say I'm investigating weird connections on this system. All right. So I can use this command, which we'll talk about here in a minute, lsof -i -P. And I can look at all of the open iNet connections. And here you can see I have my netcat listener listening on port 2222. And we're going to spend more time with LSOF. You're going to do a lab. You're going to do exactly what I'm talking about. But you can see that the process ID is 3321. All right, 3321. So what I can do is I can cd into proc, and then I can go to 3321 into that memory of that process, because proc doesn't exist on the file system. It exists in memory while the system is running and doing stuff. All right. So now I'm in that process, and check this out. You can see the exe there. Let's say I'm researching malware. I can do this. I can do strings against the exe and pipe it through less. And now it's going to show me all of the printable strings in memory for that executable that I'm doing analysis on. Okay. So you can go through and you can see all of these shared object libraries. We're looking at some of the source code. We're looking at the glibc libraries that are being used. We have format strings that are showing up in here. Other random gibberish, just keep going, hitting space bar. You can see that it does TCP, port number, format string, format string. We have all of these different things that are showing up. But if I go further down inside of this executable in memory, I'm able to pull down things like the usage information for what this executable is. So in it, it basically comes back and it says Yes, they do use the same file structures for Debian and Ubuntu. Yep. So you can see the name of the executable. If I was researching this is Netcat, this is what it does. These are the different flag switches that make it work. That's really, really powerful. And all of that's going into the proc file system and looking inside of that process ID to understand what that process is doing as well. All right. So that was, oh man, I got off of this a little bit, didn't I? Well, I think I was doing it this way. So let's go back to the top level directory. We did proc. Root is root's home. This is just the home directory for the root process or the root user. And we have all of these hidden files in root, but root is the all powerful account on this computer. So let's go back. So instead of it being at home, it's got its own. CD run are just some more binaries that you can see in here as well. Why they do it, I don't know. We already have opt, we already have bin, but they do have run in here as well. It's just another place where they put executables. Not happy about it. Got to live with it. And Snap is a package manager. So you can install packages very, very, very easily on Linux and Unix. You can do it with Docker. You can do it with Snap. You can use it with like APT, Advanced Packaging Tool. There's a whole bunch of really, really super cool free tools that you can install on Linux. Let me see if this has Synaptic. Doesn't. Let's go APT. So I'm just going to install a package on the system really quick. So I just used APT. And actually, I don't think it worked. Nope. Let's do an update first. Yes. I think I need to do APT get update. So right now you can see all of these different like links that I'm going to. They're called mirrors. And you can see I have download, Kali, rolling, release, main, contrib, non-free sources, main, contrib. So these are all package repositories for programs that I can install on my Linux computer system. So imagine on Linux that like everything is free, right? And I can basically reach out to the internet and I can download this massive catalog of all the free software that I can run on my Linux computer system, right? So there we go. So now I just did a re-index on all of those libraries and the different like catalogs. Now I'm installing a tool called Synaptic, all right, which is just a front end for these different packages out there. So it went out, it downloaded that tool, automatically installed it on my computer system. I didn't have to go through and download a binary and install the binary and then process the binary. I didn't. I just had to use this wonderful little APT tool that magically goes out and downloads these programs for me. All right. So give me a second. It's reading the database. It's running a little slow. It's not a lot of resources on this system, but that's okay because it's free and it's running. So I'm going to let that run for a couple of seconds and we'll come back. I want to finish out some of the directories that we have as well. Let me go to a different terminal. I'm going to kill my netcat listener. We're going to bignify this as well. We're going to go to our settings and we're going to go to the appearance and we're going to set our font to 20. There we go. And we're going to apply it. Great. Now, let's go back to the top level directory and let's go ahead and let's talk about, we got server binaries, we have system executables, user. I'm going to go to that here in a second, but I want to talk about var. Var is for variable files. So you'd have logs. Logs are written constantly on a Linux computer system. So that would be variables. Now, usually, back in the day, that would be a completely separate drive with a completely separate spinning hard drive. Because you were constantly writing to the var directory, it was expected that it would have a shorter mean time between failure. So you would do some of these directories that have lots and lots and lots of read writes. You would have that be on a separate device. So if it crashed, it didn't bring the entire system down, which was kind of neat. But now if you go into the sbin directory, let's go to sbin. These are system or service binaries. These are binaries that you would use to manage the system. So you can see we have WPA supplicant, we have WPA CLI, WPA. That allows us to modify the wireless configuration of this Kali instance. So a lot of these programs require root level permissions to run, and they allow you to change the configuration of the system as well. So those are system or service binaries. Let's go into user. Now, this is kind of crazy because if you go into user, we have user bin, that's user binaries. We have user games, that would be games, right? User include and libs, lib3264. See, you still have that same structure where you have the libraries, you have the binaries, you have the configuration for these programs, but these are user programs. These are not programs that are services that are going to stand up that are running as root on the computer system generally, which you have there as well. Now, with this, how do I know where a program is on a system? Well, one of the things I could do is I could do which and then the name of the program that's interesting to me. I could do which ls. And it says if I run which, it's going to run and it's going to be aliased back to the ls command, which nc. It's going to say if you run nc, it's going to execute it out of the user bin nc directory. Where is it getting this and how does it find these things? So how it's actually finding these things is something called your path. So if we look at our path, if we look at $path, this is the search order when you try to run a program that it's going to look for the program. So it's going to look into user local sbin, user sbin, user local bin, user bin, local games. It's going to look through all of these different directories, right? So that's pretty cool. And by the way, the concept of a path exists in Windows and it exists in Linux as well. So I'm going to become root real quick. Become root. And I'm going to run Synaptic. I already installed it. Did it error out again? Oh, here we go. Hold on. I'm not done installing it completely. All right. So you have all of these tools that are available in Linux and Unix. And like I said, I think this is why it's my favorite operating system, right? I think it's my favorite operating system because like literally everything is free and it makes troubleshooting things vastly easier than a Windows computer system because I have a lot of tools that allow me to figure out what is executing, tools like LSOF, which we're going to talk about after the 10-minute break here in a little bit. But it also allows me to install applications super easy, and the stuff's all free, which is just really, really cool as well. All right, so let's talk a little bit about users and privileges. My favorite version of Linux is just straight raw Debian. From straight raw Debian, I would move to Kali, and then from there, I'd really probably move to an Ubuntu distribution. But I like straight raw Debian is my favorite that you can use. All right, so users and privileges. You've seen me become root, and that's because some of the things that I've done this morning are privileged things. I have to be root because I'm messing with configurations or I'm messing with files on the system. And that requires a high level of privileges. If I have a $sign, it means I'm not root. If I have a pound prompt, it means I am root on the computer system. Looking at hidden files, we already talked about hidden files. They're basically a lot of config files that you don't want to see every day. I use the analogy of the hood on the car. I don't want to see them all of the time, but I want to know that they're there and I want to be able to pop open that hood and work on the system if I want to as well. I'm watching it all along and unable to run the VM. Will it be able to grab the cert on the last day? Absolutely. But you should be able to run it in the cloud. So we aren't doing the virtual machine. Like all the stuff I'm doing is meta CTF. If somebody can get Extra Life Jingle, the link for Google Docs to be able to gain access to the labs in meta CTF, that would be awesome. So, oh yeah. So I want to check something. Do, 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 do. Okay. I'm going to delete. Oh, that's the one I want. Good. All right. Looks like we're doing fine. I just need to check something real quick. There. All right. So we talked about those hidden files. I can make a directory with just make dir. All right. And everything's recorded, by the way. If you're a little bit behind on life, it's perfectly fine. Um, Oh, wow, that's my son calling me, and that's very buzzy. So I can make a directory using make dir, super easy to run. Now, I talked about finding files. There's a number of different ways to find files on a Linux computer system. I can touch a file and I can do something called update DB. And when I run update DB, it goes through and it indexes the entire file system of the Linux computer system. So I can then do locate a file of that name Sasquatch, right? Editing files, please bookmark this page. Actually, take a picture of this with your phone. There's a lot of different text editors that are out there. People get really worked up over the text editors that they can and cannot use. And they like Nano, they like VI, they like Vim, they like Kate, they like all these different ones. But I'm going to be a little bit controversial and I'm going to say learn VI first. If you're getting started working in Linux and Unix, learn VI. And literally the only commands that you really need to know to get started with VI are the ones I have on the screen. VI can be ran to like do your dishes if you want it to. It's crazy how amazing and things you can do with VI. Just learn these commands to get started. So VI, you would use A to start editing. You can hit escape to stop. You can write W quit to write quit and break out. And when we type the colon command, you can see that I said press colon WQ. You have to do that colon because as soon as you type colon, it means that you're no longer talking and trying to edit the file, but you're telling VI to do something. You're giving a command to VI itself on that as well. So just this is what you all need to know. If we could pin this over in resources, that would be great. You're going to need to do it. Now, an alternative to VI is Nano. Now, why would I tell people to learn VI instead of Nano first? Because Nano looks easier. If you look down, you have these helpful usage guides where you see that little caret, it's a control. So you can do control and W to search. You can do control O to write. You can do control R to read. Why would I say learn VI first? Yeah, VI is there. In almost any distribution that you're going to be running, VI is going to be present. It's going to be there. It's got you. It's got your back. Nano may not be there, right? So you may have a number of different text editors to choose from, but VI is always going to be there and you got to understand it at a basic level. But Nano is pretty cool too. We can look at processes with PSAUX. If I want to see what's running on my system, I can do that. I can do PS and AUX like so, and it'll show me all processes sorted by user, including the ones associated with a teletype or pseudo teletype terminal. There we go. I got Synaptic. All right, finally. Um, let's go. Exit. Let's do sudo Synaptic. Like that. Forget it. Screw it. I tried to show Synaptic. There's other package managers. I'll get it working and come back. But with PSAUX, I can see all of the processes sorted by user and the ones associated with the teletype terminal. Pretty cool. The other really, really super cool thing is top. So there's other versions of top. There's a lot of really, really super cool things out there that you can run. But this is awesome because it's going to show you exactly what is running on the system, what's taking the most CPU at that specific moment in time. Really super cool. So you can watch what's going on. There's also other versions. I don't know if BTOP is on. Nope. I could try to do this again. Let's try this again. Let's go APT BTOP. See if this works. See if I can get one of these things to work. Because I'm like, oh, you could install all kinds of cool things. And then it's just blowing up all over itself. All right. So we went out to the internet. There we go. There's BTOP. So didn't have it. Can install it super easy, super quick to get it running. To get out, just hit the Q key. Just hit the Q key. All right. So IP info, you can get IP address information. Remember, we talked about those IP addresses as like your phone number. We can get that with a tool like IPA, right? You can get that. I use ifconfig because I use all of the old tools that are out there to be able to get my configurations, but IPA works just fine as well. And it has it color coded as well. So pretty nice. Ping, if I want to find out if a system is alive, I can ping it. I can just go ping 8.8.8.8 and You can see that that system is alive and running. So we have 64 bytes we received from Google, and it's got the sequence, the time to live, the time response for that round trip time to Google out there as well. All right, I can also check open ports on systems with Nmap. We're going to spend more time with Nmap. We got other labs with Nmap, but Nmap is a port scanner. I talked about like the house and all the different ways in. Nmap is a tool that'll scan to identify the house and all the different ways into that house. I always recommend ping port parse. You're going to see me talk about this a lot. Anytime you're troubleshooting, ping is the system alive. Port is the port I'm trying to communicate with, open. And parse any of the errors that I'm receiving or anything that I receive back. And I can do that with Google searches as well. Network connections, I can look at it with Netstat. I don't use Netstat. You totally can use Netstat. And we're going to see Netstat on Windows as well. Not a fan. Not a fan of Netstat on Linux or Windows. It's just not my jam at all. But the better one that I like better is LSOF. So if we want to see, this shows me all the open internet connections, gives me it very clean, gives me the name of the executable, gives me the user associated with it. Chef's kiss. And we'll have a lab where you're going to be running LSOF to deal with this. We already talked about proc and processes. I showed you that earlier, how the proc is a file system where we can jump into a specific process ID and investigate that particular executable. So I jumped ahead and did all of this and got out of order and did the strings thing as well. Finally, bash history. So I can look at my history, and these are all the commands that I ran. Now, there's something really weird in Linux and Unix-based systems, many of them. If you hit a space and then you run a command, it doesn't save it to your history. So if I take this LSOF command and I put a space in front of it, it's gone. If I do a, let's do space, space W, W is gone. Really, really weird. Super, super weird. Just a way to hide things from your history file. I don't quite understand why they built that into the operating system. I'm just going to say that's kind of weird. All right. Look at that time. Look at that time. Top of the hour. We're moving into a Linux command line lab. Yes. All right. So we're going to go ahead and go to GitHub. And I'm going to give you the link. I like it when everything works. It's almost like I've done this before. It's kind of weird, strange. All right. So let me give you the link to navigation. Here you go. There we are. And we're going to be doing the Linux CLI lab right here. I'm going to share that one with you all as well. So we're going to be playing around with these different commands, and you're going to open up 3 separate Kali terminals. You're going to become root, and the first one, you're going to basically run this command make node backpipe p. When we come back, I'm going to go through this slower and kind of explain exactly what's going on. But I told you that everything in Linux and Unix is a file, and we're going to be playing with a special device file. Ooh. And it's called a backpipe. It's a first in, first out device file, and I'll explain more details about what it is. It's denoted what type of file it is by P. The name of it is backpipe, right? Then we're going to run this little Linux backdoor one-liner. We're going to do bin bash backpipe. We got this weird stuff with zeros and ones because it's all zeros and ones. And then we're going to run our netcat listener. And then we're going to open up another command and we're going to connect to ourselves. Now, your IP address will be different. You're going to see this show up again and again and again, but your IP address will be different. The labs will be like available as long as MetaCTF exists, as long as you have credits. And you have 16 of them to start. You can run it on that as well. All right. Then you're going to run some commands, and then you're going to open up a third Linux command line to hunt the malware that you created. You're going to become root because we're going to be doing some heavy stuff and finding that malware. We're going to run LSOF to find that open INET connection. We're going to get more process information about what files are open with that particular backdoor. We're going to look at our process and PSAUX. Then we're going to CD into the proc file system. We're going to run strings against the executable and get more information about what the malware is. All right. So that is the last. So going to do the walkthrough. So let's start there. So I'm going to start at the very beginning. I have 3 terminals that are running. And in one of those terminals, I'm going to become root. We'll just start with that. And I'm already root, but I'm going to run the command anyway. So we're now root. And then we're going to make this wonderful little FIFO device file with the name backpipe. Now, what exactly is a backpipe? So in Windows, you have something called inter-process communication shares and ways that you can have different processes communicate with each other. And developing kind of an analogy that I think works really, really well. You've seen movies with haunted houses, right? Where you have the haunted house, and in the haunted house, you have ghosts, you have ghouls, you have goblins, but you also have these hidden passageways. And these hidden passageways allow you to move around within the house in such a way that you're not seen, right? They're secret passageways. You also see this in hotels where you have the main part of the hotel and then you have a conference center, but behind the conference center is another hallway with a whole bunch of kitchens. It's basically a way for things to move around in a hotel or move around in a haunted house. Or, if you ever go to Versailles in France, where you can have staff gain access to rooms without actually, walking through the main hallways. That's what we're doing. We're creating this FIFO device file that allows us to communicate in processes without having to open up a network connection to go about doing it. All right. Question was, do we need to click destroy after the full training course? You can do it after each lab. It doesn't really matter. I like to blow everything away to start clean. Just works well. All right. So now we're going to go through this mess of a command where we're using that backpipe to communicate with the processes that we have running. Now, what are the 2 processes that we're communicating with? So if we go through, the first thing that we're doing is we're invoking bin bash. Bin bash is literally your command prompt. Like I'm typing in bin bash, or actually it might be like Z shell, but bash is just a command prompt that allows you to talk to the computer system to execute various commands, right? So you can execute commands like ls, who am I, and things like that, all through bash, pulling that data back. Fair enough. Then we get to this weird backpipe thing. Now, when you're looking at the backpipe, we have the backpipe show up 3 times. That doesn't mean that there are 3 separate backpipes. What it means is that we're invoking the exact same backpipe and reusing it 3 separate times. I like to think of it as like a TARDIS or a magical teleportation device that allows us to move data around wherever we want that data to go in this particular backpipe. So we have this backpipe and we have this backpipe. What is the difference between those two backpipes? Do you see the 1s and the 0s? Let me explain what those are. On Bash, on Linux systems, and even on Windows computer systems, you'll see 0s and 1s referenced at the command prompt. Those are representing standard input with a 0 and standard output with a 1. That means I can take data and I can put it into standard input into a program. That means I can take standard output with a 1 and I can dump it into another program. I can redirect the input and the output wherever I want that input and output to go. Now, if you really want to think about it and get really worked up and be like, oh, what is going on? This seems like something that I'm not quite understanding. That's perfectly fine. A lot of the stuff that we're discussing here took some of my best friends an entire week, multiple 6-packs of beer to figure out. So I don't expect people to look at this and I'll explain it and be like, oh, well, it's super simple. Anyone can figure it out. You're a moron. No, this is not super easy peasy pumpkin squeezy or lemon squeezy to do. By the way, are you a lemon squeezy person or a pumpkin squeezy person? Just getting a little bit of clarification. I don't know. Different parts of the country, it's easy squeezy, lemon squeezy, and some of it's pumpkin squeezy. Weird things. Looks like it's a whole bunch of lemons. No, I'm not making that joke. All right. So we have these backpipes that allows us to move that data from one side to the other. Now we take this pipe and we execute netcat listening on port 2222. So we're going to be listening on port 2222. Anything that's received in to port 2222 is going to come out of standard output, which is represented by 1, and it's going to be put into a backpipe. As I mentioned, a way to think of the backpipe is the magical teleportation device that allows me to move the data from one side to the other. So as soon as it enters the backpipe, anything that enters the backpipe here is going to be put into this backpipe and dumped into bin bash. Like I said, don't get wrapped up too much on this. And if you want to, you can go to this really cool site called Explain Shell. And explain shell will, you can take in the different commands that you're running and you can put it into explain shell and it'll tell you what it actually does and allows you to highlight each part of the command explaining what it's actually doing. All right. So there's a bunch of really cool things that you can do with this. You can play around with it, but just know what we're doing is we're creating a one-line backdoor on this computer system that's going to represent malware on this computer system. So I'm going to hit enter on that. Got that ready to go. I have another command prompt open. I'm going to go ahead and type in ifconfig on that one. So we got our backpipe there. I'm going to paste it in, and I've got my IP addresses 10.10.111.50. All right, let me close that. There we go. And now I'm going to connect to myself on that one. So I'm going to type nc. I'm going to put in 10.10.111.50 on port 2222. Now, some of you, when you ran that command, you forgot the port number. You need that port number for it to actually make the connection all the way through, right? So now I've made said connection and I can type commands like ls, id. I now have remote shell on myself. So we have malware. All right, so we have malware sitting on this computer system in the form of this one-line backpipe command. And we're ready now to start investigating that malware on the system. All right, so what I'm going to do over here, I'm already root, but I'm going to start with, what command do I start with here? I become root. I'm going to start with lsof -i. I want to look at all of the open internet connections or inet connections with the I. And P means don't try to resolve what the port number is. Just give me the straight dope. Tell me exactly what that port number is. And you can see down here, we have a listening process. That's our netcat process. And we have the process ID of 11479. Now, if I'm doing an investigation on this, I'm going to want to drill into that process to investigate what that process actually is. So I can do lsof again, and I can use lowercase p, and I can put in my process ID 11479. And now it's going to show me all of the open files associated with that process. So as you can see, we have a whole bunch of things associated with it. What is the root directory, because it's running as root, the current top level directory, what is the binary that's executing, it's the netcat executable, what are the shared object libraries that are used. We can see that it's invoking a pipe, it's invoking root, it's got access to a teletype terminal on the system, and it's listening on a port. Now, I went through that kind of fast, but the point is, if you're ever investigating malware on a Linux computer system, it becomes incredibly powerful and super easy for you to do that investigation, to start looking at the different object libraries that are associated with the binary, tells you what that binary's purpose and existence in life is. All right. Now, let's say hypothetically, I don't even know what that executable is at all. I just don't. How would I find out more information about that executable, right? If I have the executable, I can just simply start reverse engineering the executable. And there's a lot of people, Google is a great example, that would say, well, you could just grab the executable, run it through a decompiler, run it through Ghidra, run it through IDA Pro, and do some analysis. But we got a great point there. Google what though, right? So we can investigate this executable by looking at its process ID. So I can cd into proc, and I can go into 11479, the process ID, and I can run strings against the executable, pipe it through less. And when I do that, I'm seeing all of the printable strings within that executable, and it's going to give me an investigative capability into what that executable actually does. All right. So you can see the libraries, you can see all the different errors that it can throw. But if we scroll down far enough, once again, you're going to see the man pages for this particular executable. You can see it's OpenBSD netcat. You guys want to try something weird? Do something a little bit crazy? Of course you do, because you're like that. I knew I'd like you guys. All right. So let's go ahead and let's rerun this in a different way. All right. So what I'm going to do is I am going to go into the home Kali directory. And in here, I have a version of netcat, right? And it's one that runs inside this directory. And I can move that netcat to, let's go to not netcat like that. So now I have the not netcat executable. All right. So what I'm going to do is we're going to rerun that exact same lab, but I'm going to do some weird shenanigans with it. Okay. So the first thing I'm going to do is I'm going to make node backpipe P again in this directory because it has to be in the directory that I'm executing. And now I'm going to rerun my little one-liner backdoor, and I'm not going to have it execute NC. No, 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 no. Instead, what I'm going to do is I'm going to have it execute not netcat, which is the exact same thing. It's the exact same executable, but I've named it not netcat. All right. So I'm just going to rerun this whole thing, but we're going to run it with an executable in this particular directory. I am going to connect to it just like we do, because that's what heroes do. We're going to connect to it. There we go. And it still works. All right. So I have this netcat executable that is running in this particular directory. And I'm an evil attacker, and I want to do something a bit weird. I'm going to RM not netcat. I just deleted it. So now my malware is gone. But if you notice, it still works. Netcat itself is gone, but it's still working. So this is one of the tricks in Linux, and it even works on some Windows executables, where I have deleted the evidence behind me. Okay. So now if I'm doing an investigation on this computer system, all right, if I'm doing an investigation on this computer system, I can do the exact same process, right? I can do that LSOF. Oops. I can do LSOF minus capital P, lowercase I, and I can still see I have that notcat executable right there. That's flipping weird. It's gone. I deleted that executable and it still exists. And the reason why is if you delete the executable while it's running, it still exists in memory. Another way that you can find that is you can do LSOF, and I can do capital plus capital L1, and this will show me all of the executables that have a link count less than 1. What the hell is a link count less than 1? If you remember, everything on Linux and Unix is a file, right? And if you have the ability to look at files, one of the things we can do is we can look at the files that have a link count less than 1, which is 0. And that means it's been deleted. So in this situation, we can see that LSOF has showed us that netcat or not netcat has in fact been deleted from the system. Now, Nathan's right. I can totally kill that process, right? And all's good, no problems, life is awesome. But there is, in fact, a problem. If I'm trying to figure out what that executable actually is, I want to get that executable back. How do I get that executable back? Let me show you. So what I can do is I can cd into proc, go into the process ID for the executable. So let me pull that process ID out. Let's go lowercase I, capital P. So, and you can see that we have this 11627 11625 rather, 11625 process. So what we're going to do is we're going to cd into that directory. Okay. So now I'm in that directory with the deleted process in memory. All right. So I have that process. So now what I can do is I can copy the exe, right? And I can copy it out to, let's say, let's do temp um, backup exe. All right. So now I've taken that exe and I've carved it out of memory while it's running on this particular computer system, and I can cd into the temp directory and I can do my strings against it, right? And there's my whole executable, right? And once again, I can pipe it through less and I can start doing investigation just like we did in the lab. And now I can find out exactly what this executable is. So the process that we went through is actually a really important process for us to be able to investigate situations where the attacker has deleted the evidence behind them, but it's still running, but now we can extract that evidence. Now, why didn't I just do strings analysis against the live executable? Why did I copy it to a temp directory instead of just running it directly against the evidence that's running in memory? Yep. Because it may change. Don't want to change it. It's possible it could be deleted. I don't want any of that happen. I want to copy it as fast as I can. I don't want to do that analysis right away because I'm going to do the analysis, but I want to copy and preserve the evidence as quickly as I can as part of this investigation. All right. So that was a good long hour. We had a lot going on. Now, when we get done with the break, we're going to take a quick 10-minute break. We're going to move and redo the exact same thing, but now we're going to be doing it with Windows and the Windows command line for the rest of today. All right, let's talk Windows. All right, so Windows endpoint analysis. So let's talk a little bit about how the Windows operating system works and the different command line things that we can run on a Windows computer. We also have some really cool PowerShell scripts that we're going to share with you as well. And some people ask, like, why in the hell did we start with Linux and networking? Wouldn't it have made more sense to start with Windows? No. And the reason why is because if you look at Linux, we use Linux in this lab to create malware. And if people haven't touched Linux, it's really confusing, creates lots of problems. And on Windows, whenever we're talking about ports and services and things like that, it's really confusing because they don't understand networking concepts either. So a lot to unpack there, but the point is, it's much better to end with looking at Windows than it is to start with looking at Windows. So let's dive straight in. So we're going to be focusing on what happens when bad things happen in an environment. So we're going to be going through some of the core live Windows forensics commands that you're going to use. These are commands that you should know and you should love. They should just be part of your DNA at some point as well. It truly can mean the difference between a quick incident and an incredibly long, painful incident, which brings me to one of the key problems that I run into in this class and what I teach. I have a lot of people that show up to these classes and they say, yeah, this is all fine and this is all good, but I just use SentinelOne. I just use CrowdStrike. Can't you just show us how to use a magical tool and the magical tool is going to just magically take care of all of my problems for us? Great. Do you want to become a pod person like in the Matrix? Because this is how you become a pod person in the Matrix. Whenever you're looking at all of these things, you're like, what is the magical AI tool just going to do my job for you? That's how you become unemployed. Bill, Jim, Jake, whatever your name is, don't do that. Oh, take the red pill? I don't know. I don't know. Blue pill. I can't remember which pill it was that was reality. Take them both. Hell, who cares? Screw with Morpheus. But the point is, you need to understand how these things work. You need to understand how these things work. I work with companies all the time that get compromised, right? And I work with analysts that know how to use their magical EDR tool. But as soon as I start asking additional questions like, hey, we need to pull out prefetch files or we need to pull out the event logs to look at the 4792 event IDs, and they're like, I don't know what that is, right? The other problem that you run into is if you don't understand what's going on underneath the hood, you get tied up in that one tool. And if you end up going to another job, if you're like, oh, the only tool that I know is CrowdStrike and that's it, your career is severely limited. This is a really long way for me to just bluntly say you're effed. We're trying to make it so you're not messed up and you're not caught into this really lazy cycle. So let's dive straight in. We're going to start with network connections. Why in the hell are we starting with network connections? Now, it's kind of like with me, I sit around and I just, I'm hanging out in my garage. I might do some rock climbing while you guys are doing labs. I've got a rock wall right over there with an auto belay system. So I might do some rock climbing, but I get lonely. By the way, those wonderful, wonderful pencils, too cool to do drugs, Nerf, go to the Spearfish General Store and we have the exact same pencils that say too cool to do cybercrime. Somebody can share out a link to that. You can buy those pencils at our store. But we're going to start with network connections. Why exactly are we going to start with network connections? Because you have to start somewhere. You have to start sometime. What better time than now? What better place than here? Because all hell can't stop us now. So we're going to start with network connections. And the reason we're going to start with network connections is it's easier to work back from network connections. If you're looking at processes and you're going to start tearing apart processes and reverse engineering processes, you're going to have a bad time. Like it's going to hurt the entire time that you're trying to do that. Because if you're looking at the processes on a Windows computer system, there's a lot of processes. There's far fewer network connections, and you can pull that back that way. So we're going to be looking at Netstat, we're going to be looking at NetView, NetUse, and NetSession, which are all different. So blame Bill Gates, everybody, for lots of things, but blame Bill Gates. So we're going to start out with NetView. So if I jump into my handy dandy RDP session via Guacamole, we're going to look at NetView. Now, NetView, when we're like pen testing, we will run NetView to identify the available shares to our pen testing team. Because if you run NetView by itself with no like / 127.0.0.1, it's going to show you all the shares on the local network that you're connected to. And when we're pen testing, we run that command to find shares, mount those shares, and then exfiltrate data and files off of the environment. However, when we're looking at NetView in and of itself by itself, and we're doing analysis on a Windows computer system, we're seeing if there's any shares on the system. So I can do NetView like this, and I can do 127.0.0.1, and it's going to tell me if there's any shares. There are none. Okay, cool. Why am I interested in shares as a defender? One of the primary things that attackers do is they compromise a single Windows computer system. Then they use that Windows computer system as their primary point of entry into that environment. So they'll create a share on that system that is exposed to the entire network, compromise other computer systems, and then they'll exfiltrate data to the share and then pop it off of that computer system. So they create the share on the computer to move files to from other computers to exfiltrate off. Now, if we're going to be looking at the shares on Windows computer systems, what are one of the things that you would want to do before you get into a real incident and you start playing around with shares? What would be the first thing that you would want to do? Any takers? We'd want a baseline practice, right? We would want to baseline what is the normal shares on a Windows computer system and understand that there might be deviations, and those deviations are the things that we're going to investigate. All right, so that's NetView. What is normal? NetSession. All right, so I want you to imagine a centipede. I want you to imagine a computer centipede, right? You have one computer is the initial attack and compromise computer. It then pivots and makes a connection to another computer system. And then that computer makes another pivot and connection to yet another third computer system, which I don't have three hands, but I have three nodes: initial compromise, medium intermediary system, and another endpoint. When you're investigating that middle computer system or any of the computer systems, we have to be asking a number of different questions. What are the network connections open to that computer? What are the open network connections leaving that computer. So who am I talking to and who's talking with me? With net session, I can run a command and I can get a breakdown of who is talking with this system. Once again, there's nothing here. I can do net session and it says there's no entries on the list. There's no one that's actively connected to my computer system, right? Now, that is one thing, right? We can look at who's making that connection inbound, but we can also look at who am I talking to? So I can run net use like that. There's no entries on the list, right? So you're going to see this in the lab. We're going to make these connections with your Kali system. It's going to be mounting shares. It's going to be beautiful. You might cry a little bit, and that's okay. It's okay. We're strong enough in this class. We can, in fact, cry when we come across awesome commands. None of these commands are that awesome yet. We're going to be getting into some really awesome Windows commands here in just a little bit. Netstat, we're going to get something on. Now, Netstat, we're going to basically make it do really cool things. But let's start at the very beginning because it's a very good place to start. We're going to do Netstat by itself. Netstat by itself is going to take a few moments. It's going to show us all of the open network connections on this system and who they're established to. Woo! Wow, look at that. We have local address, 10.10.124.181 foreign address. We have, RDP sessions, HTTPS sessions. We're getting started. We're getting started here. But we have the IP address, we have the protocol, the source, the destination. What's missing from this? We've got the state of established, which I guess is cool. What's missing? What would you like to see here? Yeah, ports would be cool, even though they're there. The ports are there. You can see the HTTPS, HTTP. Process ID, right? What's the application? So by itself, Netstat is just sad. I mean, by itself, it's just this little lonely command that just doesn't give us a lot of information. It's like the OSI model of commands, but we can make it better, right? It's like those really messed up relationships where you're like, I can fix them. We can, in fact, fix them. So let's talk about some ways that we can fix it. We can take Netstat and we can add some switches. We can add naub. What the hell is that? Well, the A means display all active TCP connections and UDP connections. N means display active TCP connections, but give us just the numbers. Don't resolve anything, just the straight dope. Want the numbers. O, I want to see the process ID. Process IDs. And B, I want to see the executable involved. So now we can go from this. We can do Netstat, and now we can do TAC NAOB. Why do this when you can have this instead? All of you are going full Kevin McAllister at the moment. This is cool. Let's go ahead and let's scroll up and look at some of these things. Like, that's a lot of data and I just spit all over myself. That's not something anybody wanted to hear. I could have just skipped right over it. You probably wouldn't have even seen it, even though it is a 4K camera. No one wants to zoom in that much. So here you can see what is the listening port, the local and foreign address. Is it listening or is it established, and the process ID, and what is that process? This is powerful stuff. Generally, you want to focus on the established or SYN sent connections. So here you can see these are all of the established connections. You can see I have a terminal server connection, which is, of course, me connecting to myself. That's me, right? We also have a lot of SVC host. Ooh. I also have Elastic Agent running on this system as well. So we have a lot more data. Now I'm getting what is the connection, I'm getting what is the process ID, and I'm also getting what is the binary. Now, Extra Life Jingle had a great question that I think is fantastic. It's one of those questions that pops up when you're doing expert witness work and depositions. Ask the question, cannot obtain ownership information, and I'm running it as administrator. That's weird. Anything that's running with the system process, with a process ID of 4, comes back and says, cannot find or cannot obtain ownership information. There's other really, really high level processes like the Local Security Authority Subsystem Service that are standard Windows services that Windows cannot obtain the ownership information. Doesn't mean it's malware. It just means it's really a high level process on that computer. Great question. All right. We also have some other things going on. Maybe you're starting to see it. There's a couple of these that keep showing up, like SVC host. What the hell is that? Stay tuned. We'll be getting to that one in more detail. So that's what Netstat NAOB means. We can also try to do this command, which sucks, honestly. I think it's nothing but an absolute disappointment. It's kind of like, that child of yours that went into political science, right? It's just nothing but disappointment. Now, some of you are getting offended right now. You need to stop, collaborate, listen, listen, listen. I'm a poli-sci major. See, it's okay. I'm making fun of myself. I'm a proud poli-sci major from the University of Wyoming, but I'm not going to lie. Parents were a little bit disappointed. A little bit disappointed. So, like I said, this is one of those commands that should be just absolutely awesome, but it's not. So the netstat -f command is designed to do name resolution. So whenever we're looking at the foreign addresses, instead of just giving us the raw IP address, it's supposed to come back and do a fully qualified domain name resolution of that IP address. But you can see it doesn't work. All right. It doesn't work all the time because a lot of the different services, if we're looking at like update services for Windows, those services, they totally just go straight to IP addresses in some situations. So that does happen. But if you want to get name resolution, you can do it. Also, just a quick note, let's say I went to a website. What would be a website that has lots of ads? Let's go to Yahoo. Yahoo.com. All right. I might have gotten those jingles wrong. So I'm at Yahoo, which is also known as just a nightmare of ads, and it's loading a bunch of them. Like, look at all of this stuff. We got the list, we got finance, we got sports. Just not happy, not a good thing. So now, if I go back to my command prompt, once again, back to the command prompt, because we're going back. I can't do Aerosmith. I just can't. So now I'm going to rerun that command and oh my God, what happened here? Oh, geez. Oh my God. I just opened up. What? It keeps going. Why? This right here, this is right here is why people that are broken support like Internet 3.0. Web 3.0 people are weird. Don't ever party with them. They're strange. It ends up with like very, very weird designer cocktail drugs. Don't ask me how I know. But I just went to Yahoo, right? What the, what? Oh, I'm still scrolling. What is this? That's one website. Went to Yahoo. Oh God. Okay. So let's have a moment. I'm going to calm down. Going to calm down. Whenever you go to a website like yahoo.com, it basically fractures and it redirects you to a whole bunch of ad and tracking and content delivery network sites that are giving you more ads and more tracking because they can't track you enough. I mentioned Bo Burnham the other day. Bo Burnham was interviewed right before he disappeared and then worked on Inside. And he said, the powers that be are coming after every possible moment of your attention, every possible moment, and they're going to try to telemetry and track the hell out of you in the hopes of trying to sell you more crap. This is what that looks like. I mean, this is nuts. And if you're working an incident, I just want to throw this out there. If you're working an incident and you got a hack and you have to go through this, welcome to hell. It's bad. So in this class, one of the things I recommend is how about, you kill ads, right? Like right on the edge of your perimeter, just black hole them. Black hole ads, won't you come? Okay. Doesn't work. Can't do Chris Cornell either. That's actually not true. I do a great Chris Cornell. So come to Denver. I'll do Hunger Strike. How does that sound? Come to Denver next week and I'll sing Hunger Strike karaoke style because we have karaoke. But you need to kill the ads. You need to kill the ads because if you block all of the ads that are out there, it drastically reduces the amount of white noise that you have to sift through when you're doing a forensics investigation on a computer system. I'm just going to close this. We're just going to pretend that didn't happen. All right, so I just killed that connection. Now watch. Let's show you something here. So I just killed my internet browser. Do you notice that there's still a whole bunch of like weird connections that are still floating around? Yeah. The reason why that's the case is Microsoft in memory isn't really super solid at clearing up the network connections in memory very quickly. So this is actually a good thing, believe it or not. It's actually a good thing because if the attacker tries to kill the malware, sometimes you'll see like ghost like connections of that malware residing. Notice it took what, 10, 15 seconds for it to completely clean out those connections. So that buys you some time every once in a while. Pretty cool. You might see something like that a little bit later in our memory analysis lab, possibly, hypothetically, maybe. I mean, all right. So let's go ahead and let's keep moving. So that's what netstat minus F looks like. Now we're done with network connections. Let's dive into processes. Now, usually your forensics kind of like methodology, you'll start with those network connections, and then you'll start investigating the processes associated with those network connections that are out there. So now we have those networks, we have some weird shenanigans. Now we can use some commands that'll tell us whether or not that's malicious or real or what type of processes we're investigating. Another super lame command, just bad task list. Just just sad. So sad. Wait a minute. Hmm. Hold on. Hold on here. Two quick things. First quick thing, I'm just going to say that season 2 of Squid Games, not happy with the ending. It's kind of like I thought there was another episode. Really should be another episode. We'll see. All right. That's number one. Number two, and more importantly and germane to this particular topic that we're on, and the reason that we are all gathered here today, if you were going to name your malware something, what would be a really good name for your malware? Yeah. SVC host. Totally not malware is a good one too. I like the way you think. Throw them off the scent. What about that? No, that's totally not malware. All right. So SVC host would be a really good one, right? Because it shows up again and again and again. And this is one of those failings, I think, in Microsoft. Like, who thought this was a good idea? So, what the hell is SVC host? Let's say you got a service. If you start that service in a normal world like Linux, whenever you ran the service, it would show you that that service is what's running. On Windows, it's like got this weird infosec IT prophylactic thing going on. Whenever you start a service, that service doesn't start directly. It's actually invoked by services controller host or SVC host. So if you're looking at what's running, network connections, processes, all of that stuff, it just comes back to SVC host. It's almost like Patrick from SpongeBob SquarePants. It's like, what's process ID 1504? SVC host. Which is 1644? SVC host. What is 2216? SVC host. Like, what the hell? Like, did you, people at Microsoft, did you actually use this operating system while you were writing this operating system? Don't answer that question because it involves cocaine. We're coming back to that later on in this class. Probably tomorrow is cocaine day. Not taking, I'm just going to be discussing cocaine as it relates to operating system creation. So if we have this task list command, which is absolutely horrible, we can make it better, right? So we can fix it. We actually can fix it. Task list space / SVC. When I use the SVC switch, it's going to tell us what are the services that are invoked out of all of those wonderful SVC hosts. All of a sudden, we go from this zero of a command to a hero of a command. Now I can run SVC host and it can say, now 1728, that is RDP service. We've got BFE MSRPC on 1644, font cache is 1620. It's now telling us what is that process that is associated and was ran at a SVC host. How cool is that, right? I think that that's a step in the right direction, right? I have hope for humanity. Actually, that's not true. We're all going to die screaming. But this particular command gives us hope for at least getting through this class and probably our next security incident and making it work as well. So that's pretty neat, right? But wait, there's more, right? Now we're getting into the mind blown commands that we can run with Windows Forensics. I can run task list space / M. Hold on to your butts because with taskless space /m, it gives us all the process IDs and all of the dynamic link libraries that are loaded into that process. That is magic. That is really cool, right? Because now I can go through and I can start fingerprinting. What does normal malware look like? What does it look like with something's trying to blend in? If somebody's trying to upload a malicious dynamic link library onto the computer system, is it a unique dynamic link library? Oh, wait, there's more because I can take that command and I can do this ntdll.dll. And now I can see what is every process that's using a specific dynamic link library. So if I see a weird dynamic link library with the name of totally not malware.dll, I can see if there's any other processes that are using that dynamic link library out there as well. Does this mean John also knows pirate software Thor? No, I don't get out much. I got to understand, like, whenever it comes to the internet and InfoSec popularity, I peaked about 2017, maybe 18, not sure. And I'm happy, like, going into the ether and letting all these YouTube kids like John Hammond scamper around. It's cute. I'm just sitting on my porch, growing out my beard, which I don't have right now, but I should, sitting with a rifle and a rocking chair and just thinking about how all these InfoSec whippersnappers are coming up. I'm damn proud of every single one of them. You too, Jerry and Simply Cyber. I'm proud of you. See, that's where I'm at. I'm that old guy, right? I got all kinds of wonderful stories to share on things like that as well. But going back to this, awesome, because now I can see if a dynamic link library is in fact a unique dynamic link library as well. Ooh, so hot this year. All right. But wait, there's more. Let's say that there's a process ID of interest. I can filter those results to just that specific process ID. So I can do taskless space /m, fi, or this is the process and the program that says, so we run taskless space /m/, and then I can put in PID equals the process ID. It's right. Team Simply Cyber forever, yo. So now I can see all the dynamic link libraries just associated with that one simple process ID. Hackers hate it whenever you do this search for their one simple process ID. The other command we can run is WMIC. WMIC stands for Windows Management Instrumentation Command. And we can do WMIC process list full, and it's going to dump all of the state and all this wonderful information about processes as well. Now, we can take WMIC and we can do additional super cool things. I can do WMIC process. That means we're going to be pulling from the process information. And I want you to get the column name, parent process ID, and process ID. And bam, I have like a PS tree. It's showing me what process begat which other process on this system. And that's just good squishy. Do we have more clips of Jerry getting horribly confused and tripping all over himself? Because I find that shit funny. And I love Jerry. But seriously, I have haircut fish all the time here, and he's popping up all kinds of wonderful gifts for me. I was there when that happened, by the way, when he was rocking out at the post party. By the way, Wild West Hacking Fest, best after parties ever. Awesome. So check it out. All right. Yes, you can run all of this inside of PowerShell because WMI is something that you can invoke in PowerShell as well. All right. So WMIC process, where process ID is, give it a process number, and then we get the command line invocation, and it'll show us where the command line invocation works. Do you all just have these GIFs of Jerry just sitting around? I'm proud of you. Maybe we're not going to die screaming after all. All right. No, we totally are. So we also have PowerShell. Hey, Fed, come on. I did that once in my basement with the camera at like 3 o'clock in the morning. Okay, maybe I did it twice, once in my basement and then once right over there. Good God. All right. We also have PowerShell commands and PowerShell utilities that we can run as well. Tools like Deep Blue CLI, look at the logs and look at things like sysmon logs to get us more information. Jesus, another $5 that give us information about whether there's potential attacks. These are great triage. labs as well. All right, so that's going to take us to the lab. Go to intro labs again. We're going to be doing Windows command line right here, Windows CLI, Windows CLI. All right. And we're going to be creating malware and detecting it on our Windows computer, those are hobbies that I think everyone should do. The first thing that you're going to do is you're going to disable the AV. I know this is a bit weird. Stick with me. This class is not a class on here's how we bypass AV. That's a different class. Go to Joff's class on endpoint creation. Completely different class. Yes, I could teach you, but we have to charge. All right. But this lab is all about how we detect malware on a computer system. So we're going to disable AV so that we can get the malware to run and then hunt it down on the system. By the way, you're going to totally get some angry red errors. It's going to be like, boom, red, angry. And you're going to be like, oh, it didn't work. I got red errors. And you're totally not listening to me now, which is perfectly fine. It's okay, but you're going to be running a command shell prompt, or sorry, you're going to be running a PowerShell prompt on your Windows computer system. And you're going to run this and you're going to get angry red letters like this, possibly, or maybe not, maybe, yeah. All right, yeah, let's keep moving on. Really uncomfortable at the moment. Usually there's angry red errors. That's very weird. Now we're nervous. Yeah. I'm in danger. All right. Then you're also going to disable your firewall. NetSH ADV firewall set all profile state off. Thank you. There's the angry red errors. That's what it should look like. There we go. And then you're going to set your password to the administrator password to something that you can remember. Sure, you can do password 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can do that if you want. That's fine. Just remember your damn password. Because many times people get later on in the lab and then they run this and they forgot their password and they're like, what was my password? Help me. I forgot what my password is. Destroy your VM and start over. I can't help you if you can't remember your password. You're going to get your IP address. Then you're going to open up your ADHD Linux system. We're going to go ahead and going to become root and Kali. We're going to start MSF console. Takes a while for Kali to start. It does. Then you're going to use exploit Windows SMB PS exec. Then you're going to set your payload to be Windows Meterpreter reverse TCP on the system. You're going to set the rhost to be your Windows system. This IP address right here is merely an articulative IP address. Your IP address is going to be different. You know it to be true deep in your hearts because it's bold and right below it in the instructions, which you will read. Then you're going to set the SMB user to be administrator, and you can set the SMB pass to something that you set it to. I have these different. I'm just using articulative passwords. I should probably change that because people just copy and paste things directly through. You know what? I might just log in and edit and change that. But your password will be different. It should be the password that you set it to. And once again, verily, I say it is the truth that you remember your password will be different. I hope. Just be careful. Should look like that, something like that, but with a different password. All right. Then you're going to type exploit. If it doesn't work, screenshot it and send us a screenshot. Don't just say, hey, it didn't work. Is it not working for other people? You're setting up a trap. I know what you're doing. You're trying to blame me, which usually is a good choice. But in this situation, screenshot your error so I can help you find your mistake. All right. Screenshot the error message because it's going to be you got the password mixed up. The IP address is not correct. It's going to give us error messages. It's going to tell us things like, connection refused. Okay, cool. Your firewall might be on. You forgot to disable that. Or it's going to say NT status logon failed. Means your password is wrong. There's all kinds of reasons why it would happen, but I need that screenshot. I need that screenshot from you. I do. Then once you're in, you're going to open up a Windows command prompt and you're going to go hunt that malware. You're going to start with netstat NAOB. You're going to run netstat -f. You're going to look at the process information. Your process ID will be different. You're going to get the command line invocation. You're going to pull out the string for just your process ID. It's awesome. Awesome. This is the largest lab that we have in this class. It's a really long lab. Let's get into this lab. And then we're going to do Jason Blanchard hunting for jobs. And then tomorrow morning, we're going to do the walk. All right, everybody. I'm going to be putting you in the capable hands of Jason. I'm going to be getting out of here. And I will be back tomorrow morning and we'll do a lab walkthrough. So, Jason, are you ready, sir?
Yeah, so like it's all mine, John.
All yours. It's all
All right.
yours, all the
All
time.
right.
I'm going to
Okay.
stop sharing so you can share.
Okay.
With that, I will see you all bright and early. So, thank you so much. Take care, everybody.
Yeah.
Jason, it's all yours.
All right. Thanks, John. Okie dokie. Hello, everybody. It's good to see you again. How's class? How are things? I'll just go and get myself situated here. All right. So before I open it up to actually like doing job hunting stuff, I do want to like, do you have any questions? Like what burning questions do you have? As we heard you show us all the open job postings, how to get noticed, search projects, 10-minute crash course fans, resume formatting. How would you set up your profile on LinkedIn? How to better market yourself? How to network in LinkedIn? Which beginner network profile? Best option moving GRC to SecOps, honestly finding starting role. All right, I'm going to start with this real quick. The first thing I'm going to start with is if you've never done this before and you don't know about it, uh, go to type in the word B-sides. All right, so in Google, type in the word B-sides and then type in the biggest city near you and see if there's a B-sides near you. All right, so for me, it's B-sides Baltimore. That's the biggest city to me, and it's B-sides Charm. What I want you to do is once you find B-sides and your big city, go ahead and drop the link into Discord. Okay, so we're going to do that first. So once you find your local B-sides, go ahead and put it inside of your fantastic. You're all doing a great job. All right. And if you've never been to B-sides, this is what I'm going to encourage you to do. All right. So if you're looking for jobs, if you're looking for work, if you're looking for something, your local network, your local people that you know will help you more over time than all the certs, all the education, all the things. Like certs, education, all that stuff is fantastic. It's fantastic. You're all doing a great job. All those things are fantastic, and getting to know the people in your local area are super important. Okay, so once you have found your local B-sides, one of the things I encourage you to do is go to the sponsors page. So they're going to have sponsors page, and then you're going to take a look at who the sponsors are for your local B-side. So if you've never done this before, take a look at who the sponsors are of your local B-sides. Now, once you find the sponsors of your local B-sides, then these are potential companies that you could do work for in your local area. One of the reasons that companies sponsor a B-sides is one, an employee that works for them enjoys the event and says, hey, we should sponsor this event. And two, they're doing it as a recruitment tool. They're doing it to find new people to come work at their companies. So if you've never done this before, you take a look at this. All right. Now, the next thing to do is if you've never done this before, it's like Meetup. All right. So Meetup, Baltimore, right? That's where I live. Cybersecurity. And it should give you a bunch of different meetups in your local area for cybersecurity. So like this one I found this morning just doing a search for some other people. It's a Hack the Box meetup in Baltimore. All right. If you don't know, also DC 443. So if you ever take DC, so DEF CON and your zip code, you should be able to find the local DEF CON group, which I just found called unallocated space. So if you're in the Baltimore, Washington, DC area, your local DEF CON group is the DC 443. And so if you've never been to your local DEF CON group, this is a great place. And like if you're in this area, they have a thing called unallocated space, which is where you can go and actually it's a hacker space where you can make things, build stuff, create stuff. And they have an open house on Wednesday, which is tomorrow, right? So you can go to this open house tomorrow. So if you wanted to go to that upcoming event, you totally could. Now, let's say you're in Austin, all right? So you're in Austin. They have the Austin Hackers Anonymous, right? So the Austin Hackers Anonymous, which If you look, it actually breaks down to AHA, which is why they call their website Take On Me. Take on me, take on me. So the Austin Hackers Association is where hackers, people get together in the Austin, Texas area. They have a monthly meeting and they can go here. Now, if you've never been to Austin Hackers, one of the rules that they have is if this is your first time at Austin Hackers, you're going to present at Austin Hackers. Now, if that intimidates and scares you, then you got to get over it. Okay, so back to the whole like B-sides charm thing. There is a tab for all your local B-sides called volunteer. If you're new to this industry or you're thinking or you're looking to get a job, please, 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 please volunteer at your local B-sides. One of the reasons why you volunteer at your local B-sides is because when you meet the other people who are volunteering, who are you meeting? Who are the kind of people that volunteer? Like, really, when you think about it, who are the people that volunteer? It's kind and generous people who like to share and help others. When you're looking for a job, who's it good to know? Well, kind of generous people who like to help others, right? So if you're currently looking for a job or in the future you have a job to offer somebody else, then getting to know the other volunteers of your local B-sides is a great way of doing it. Plus, you get to go for free to B-sides. Plus, you might work a couple hour shifts, but during that time, you get to meet the organizers, you get to meet the other people. Now, here's the thing about organizers at a B-sides. Get to know your local B-sides organizers. And the reason why is because B-sides organizers are connectors. They are the people who like to connect other people together. All right, so if I go over here to B-sides charm, I don't know if they have, sometimes you can find like they actually have a B-sides or something like this. This is something old from a long time ago. You go to people, they got some people listed here under B-sides charm, and then they also have a company here. All right, so some B-sides do actually have like a LinkedIn profile, and you can click over here to employees. They don't have any, but you can go down here to post, and their call for papers ends tomorrow. If you've never given a talk before, if you've never given a talk before, that's what I'm going to encourage you to do next. So there is Jason Blanchard. Uh, how to give a presentation, how people want to hear a presentation. All right, this is a talk I gave a long time ago on how people like to hear talks using science and stuff. So if you have never given a talk, please give a talk. And you're like, I thought we were going to talk about jobs. I am talking about jobs. If you want to introduce yourself to a large group of people all at one time as a way of networking with people, then speak. Speak at an event. And if you're like, I don't want to speak at an event, I have nothing I want to talk about, and I'm afraid of the audience. Well, then listen to this talk. I address all those things in that talk so that you can finish that talk thinking to yourself, actually, I could give a talk. So the B-sides charm CFP is ending tomorrow. All the other B-sides are happening all over the place, and so you can submit a talk for any of those B-sides. So if you've never been to cfptime.org, cfptime.org, this will give you a breakdown of all the CFPs that are currently going on at HackerCons throughout the world. And so you can go through here and it gives you when it's ending, when the conference date is, and you can go through and find all the different places where you can speak and present that are currently listed on cfptime.org. And so you can go speak. So if you've never spoken before, I encourage you to speak. If you don't know how to speak, I encourage you to listen to the webcast. And if you don't know why I even mentioned why you should speak in the first place, is because when you go to a conference, when you speak in front of a large audience, when you do that, you introduce yourself to a lot of people all at one time. What do you think I'm doing right now? I'm introducing myself to a lot of people all at one time. For those of you that are here for the very first time for an anti-siphon Pay What You Can class with John Strand, some of you just met John for the very first time yesterday, and you're thinking to yourself, I'm glad I showed up. I'm glad I figured this out. I'm glad I learned. I'm glad that I'm here. But it's a way for John to introduce himself to a large group of people. Why do you think so many people know who John is? Because John likes to speak and talk in front of audiences. You can do the same thing. And if you're like, I don't know what I'm going to talk about, everyone else is a wizard compared to me. Not everyone's a wizard compared to you. There's other people who are just learning just like you are. And here's the cool thing about talks at conferences. The person who chooses to come to your talk at a conference has self-selected that they're interested in the topic that you're talking about, which means you can be friends. You can be friends. Okay. So John goes by Strand JS on Wizard on I said Wizard. All right. So back to this. Some of you asked about how to create a LinkedIn profile for yourself. So let's talk about that real quick. Because now that you're like speaking at events and going places and introducing yourself to people, you're like, well, I want to put my best foot forward. How can I do that? And so I'm going to give you a how to do that here real quick. All right. So the worst part about putting a resume together is actually putting a resume together. All right. I think we all can agree that writing a resume is just, I don't know what level of hell that is, but it is a level of hell. One of my favorite things, have you ever seen The Pit to Hell? The Pit to Hell? I think it's in the Middle East or something. I don't know. Like it's The Pit to Hell is a real place. Okay. Yeah, the Turkmenistan methane-fueled fire pit that has been burning since 1971. Okay. There it is. All right. There's like a pit of hell. This is what I imagine writing a resume is like for all of us. Like just going and standing in a pit of hell and just like, this is great. I enjoy this so much. All right. So I don't like doing that. I'm a content strategist. Once again, I don't have a lot of time here. Also, if you have questions, feel free to throw them out any time. I'm a content strategist. Like if you were like, hey, Jason, what do you do for a living? Well, I'm a content strategist. Okay. And so what I would do is I'd go to jobs, content strategist, and find out that there's currently 436 jobs in the United States listed as content strategist. If you didn't know, you can also search by country, you can search by state, you can search by any of those things. All right. So what I would do, since I don't know how to talk about myself, I don't. I really don't. I mean, I'm talking about myself right now, but I don't. If you were to like, hey, Jason, can you take this blank sheet of paper and then talk about yourself? Here's how far I'd get. I'd get about this far before I start like reconsidering every choice I've ever made in my entire life where I'm like, I don't even I don't even know like what title do I put? Like, do I put the title that I had? Do I put the title that I want? Do I put the title that I'm aspiring? Do I put aspiring in here? Like, oh God, no. Oh God, no. Never put the words aspiring or passionate. Please, 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 please don't put aspiring or passionate into your job title. It is entry level. That is what aspiring and passionate means. Entry level. Please just put entry level, not passionate, not aspiring. That's the only rant I'll probably go on for the next 8 seconds. Okay. So when you're trying to figure out like what do you put here, what do you do, right? So I don't know. So what I'm going to do is I'm going to start searching for people who actually want to hire for the job that I think I have or job that I've had in the past. It says responsibilities, and it says post 2 to 3 pieces of content, reels and graphics daily for Instagram. Ooh. May scale up and I don't track, analyze, and leverage Insta. Okay, well, we're just gonna take. All right, so what I'm gonna do is that's true, right? Track, analyze, leverage Instagram trends to keep content relevant and ahead of the curve. That is something that I know how to do. So I'm gonna go back over here and say tracked, analyzed, and leveraged social media trends to keep content relevant and ahead of the curve. Do you see what I just did? All right, let's go ahead and increase the size here. Is that I went to a job description, and I looked for what I've done in the past to develop and execute platform strategies specifically for Instagram to drive engagement and growth. So once again, I'll go back over here and I'll drop this in and say developed and executed platform strategy specifically for social media. And if you're like, why don't you like Instagrams? Because I missed it. I missed it. I missed Instagram. I was a little too old at the time. I never got into it. There. I had an Instagram account for my dog. He did really well for himself, but as far as me, I don't need it. Okay. So develop and execute platform strategies to drive engagement and growth. All right. So why does this matter to you? Why does it matter to you? Because you can do the same thing over here for SOC analyst, right? You go over here to SOC analyst and you go ahead and drop this in. And so now you have the 1,307 jobs and you click on junior SOC analyst. And then you go, it says perform hunting for malicious activities across the network and digital assets. You're like, cool, right? Like if you're getting a job as a SOC analyst, then you say performed. If it's something you did, if it's something you're currently doing, say perform. So if I go down here, I'd just say SOC analyst. And then, wow, analyst? Really? Oh, God. No, no. All right, let me see if there's, can you show one for GRC jobs? I can. You go to where it says GRC. I don't know, GRC analyst. But we got GRC and you'd go to these cyber planner and then you go through and then like, hey, and when it says things like 9 years of experience supporting military or government cryptology, like if you don't know how to do that, then don't do it. Like don't copy and paste the ones you can't do. Just copy and paste the ones that you can. So you go over here to information security and privacy manager. It says lead investigations and be the point person for regarding incidents involving contractors, employees, right? Like if there's something here you know how to do, copy it, and paste it, copy it and paste it, copy it and paste it over here. Now, let's go ahead and bring in ChatGPT into all this because, you know, it's, you can't just do this without ChatGPT now. So here's one of my favorite things to do. You take the job summary. All right. So you take the job summary and you go like copy, right? Copy job summary. And then you go over to ChatGPT and say, you are currently looking for a role in GRC, and you need to write an about me for your LinkedIn profile. You want to keep it to 5 sentences or less using only the information most important from this text. Keep it conversational and in the first person. And then you just, so what I did, just so you didn't miss it, I took the job summary. Aren't, yeah, DeepSeek, yeah, I know, I'm using a lot more electricity than I should. All right, so you take the job summary, and because the job summary was normally written by the hiring manager, the job summary was written by the hiring manager, says, here's what we're looking for, here's what we need. And so you take the job summary, you go over to ChatGPT, and you're like, you're currently looking for a role in GRC, and you need to write an about me for your LinkedIn profile. You want to keep it to 5 sentences or less, using only the information most important from this text. Keep it conversational in the first person. I then paste that text in here, and then I hit go. And it says, I'm an experienced information security professional specializing in protective, sensitive information assets and managing security programs with a strong focus on driving security and privacy initiatives. I excel in reviewing contracts, responding to security questionnaires, and guiding organizations through incident response and risk management. Passionate about creating awareness and identifying opportunities for improvement. I serve as a trusted advisor on information security and privacy. Let's connect to discuss how I can help strengthen your organization's posture. This is fantastic if it's true, right? If it's true, then it's okay. And passionate's fine in the about me section. It is not fine in the title of your job. All right, so then you go back over here to like the actual about me section, and then you go into the about me section, and then you're like, here you go. You paste it, right? You paste that into, cool. How do you feel about third person and about me's on LinkedIn? I think of about me is the same way as if someone asked me the question like, so what do you do? Like, tell me a little bit about yourself. And I was like, well, I produce engaging content that earns people's attention and use that to build genuine, thriving communities. Send me a message. Let's grab hot chocolate or coffee and swap stories. So that's me, right? Like, there's a lot of other people out there that have lots of different opinions, but mine is, how would you say it in a, tell me a little bit about yourself? And when he's like, well, I will tell you a little bit about myself. Okay. So those are some techniques that you could potentially use. So let's recap. All right. So you go to job descriptions, you harvest job descriptions that are true about you. You then make sure that they're accurate, and you put those job descriptions into a long sheet of paper, essentially long. Uh, it's not paper. It's just a computer, for God's sakes. All right. So you put that there. Use ChatGPT where you can to actually improve the way that you talk about yourself. And I love this because here's the thing about jobs, like, right? Like, if we go back over here to what this was, they're like, hey, here's who we're looking for. It's like, that's literally what they're like, hey, this is what we're looking for. And you're like, okay, cool. I feel like that's me. So let me just reword it to let you know that I am who you're looking for. Like, this is who we're looking for. Awesome. That's I am who you're looking for. You're like, this is who we're looking for. You're like, cool. That's who I am. That's great. Okay. Sure. You can dump your skills in a list of Excel. All right. So think of it this way. Spend 2 hours harvesting bullet points. Spend 2 hours harvesting bullet points where you go through and you find everything that's true about you. And what happens is over a period of time, you will have a long list of things that you can do. All right. You have a long list of things that you can do. You know what this really does? It wipes out that imposter syndrome that you feel sometimes. Do you know what gives you imposter syndrome? I'll show you. This. Trying to look at a blank sheet of paper and think of all the crap that you know how to do. That's what gives you imposter syndrome. You're like, what do I do all day? I don't know. I don't know. I don't think I do anything all day. And then the other thing that gives you imposter syndrome is actually going to a job description and then reading through it. I don't know about you, but I know there's at least one person here that you will find the one bullet point you can't do and then go, well, wah, wah, wah. I can't do the job. I found the one thing they listed that I can't do, which means I can't do the job. I now have imposter syndrome. And then you get down here to where it says like 2 years of experience working in the field or 5 years experience working. Like, this is just, don't you have like things that you wish a job would be? Well, they can have things that they wish an applicant could be, right? And it's like, it's a give or take. Like, yeah, you didn't get all 2 years, but you got enough. It's fine. And like, what do the years mean anyway? The years just mean like, I don't have to teach you the basics. And you're like, hey, you don't really have to teach me the basics, right? Like, I got this. Okay. All right. So yes, that was a fantastic recap, Jesse. Step one, find your local B-sides and go to it. Volunteer to it and speak at it. Please, for love, just go and speak. If you've never actually spoken before, then do watch the video and then be inspired to actually speak and present and introduce yourself to large groups of people all at one time. And in the meantime, update your LinkedIn profile by going and harvesting bullet points that are true about you. And so if you want to see what the turkey looks like when it's all finished, Julia Childs style, and you're like, who is this Julia Childs you guys keep talking about? Well, it looks like this, all right? So when the turkey's all cooked, this is what a LinkedIn profile looks like, where I took, you know what, one of my favorite things to tell people, have you ever had a job? Like, have you had a job? There's a chance that the job description that was used to attract you to the job could just be the thing that you harvest bullet points from for the things that you did at your job. So whenever you get a job, just take the job description, copy the whole thing, and then paste it into LinkedIn and say, here's what I do now. Okay. Like, just take the job description of the job you get and copy it and put it in the proper tense and say, this is what I do now. Cool. How do I get a good profile pic? Mine is currently more of a mugshot. All right, real quick on how to get profile pics. Take 5 feet away from the wall, no overhead lighting, and take it on where you take the picture in portrait mode. Step away from the tree. Do not stand in front of a tree for your profile picture. Don't do it. All right. And also don't stand against the wall and don't have overhead lighting. That's the best way to get your profile picture. If there is written hiring recent graduates, aren't you someone eligible if they aren't recent 1 year? I don't know. I actually understand that question, proximity. Here's one of my favorite things about recent graduates. Like, if you go to CrowdStrike, I don't know if it does this. Let me just There are recruiters for entry-level people. If you didn't know that, there are recruiters for people who are just getting started in their industry. And it's normally where you go to and you say campus? I think the word's campus. All right. So red team, talent acquisition partner, security advisor, threat detection, security, university recruiting. All right. There she is. Katarina. So it falls under university recruiting. Her sole purpose in life is to hire entry-level people straight out of high school or straight out of college. Sorry, straight out of college. So Katarina's sole purpose in life is to find entry-level people to give jobs to inside of this large organization. So if you've never thought about looking for that before, then you can go and find the people who are specialized in early entry or I don't know if it's remote, but possibly remote. But what you can do is find recruiters that specialize in entry level jobs. All right, one last thing. For those of you that are currently, you have CompTIA, right? So like, let's say you have CompTIA or you're trying to get your CompTIA and you're like, but that's it. I've taken this class and I have my CompTIA's A+ certification. Like, okay, cool. Let's go talk about that. All right, so they get over here and it says embrace the latest trends, access to on-the-job skills, cool, about the exam. All right, the new access to, and then you go down here, what you will learn. Whenever, from now on, whenever you get a certification, it will most likely say what the candidate knows or what the candidate knows or learned. So take this stuff, explain explain in the first person how I know how to do these things. I have a solid understanding of general information. Like, you just take how they say, like, well, people are gonna know this. And you're like, cool. Could you please, ChatGPT, put it into like, I don't know, 4 bullet points and explain how I know how to do these things, right? So what you're doing is you're taking the information that they've said, here's how you do the cert, and you're like, cool, here's the things I know how to do. One last thing is make sure you do not like, it says I have a solid understanding. Just take the word solid out, all right? Take the word solid out, and then you're good to go. Hack Queen says interview tips. Yes, here's my #1 interview tip. Do not care if you get the job. And you're like, really? That's your interview tip? Yes, don't care if you get the job. And the reason why I say don't care if you get the job is because you just freeze up if you care if you got the job. You're like, if I mess up right now, I'm just gonna, if I say the wrong word, I'm just, all right. So it takes the pressure off. Absolutely, right? It takes the pressure off. Now, here's the other tip for interviews. Put post-it notes around your monitor about all the things you want to ask or the things that you want to make sure that you do not forget about when you're talking to the company. So take post-it notes, put it all around your monitor. On the right-hand side, you can put all the questions that you want to ask them. And on the left-hand side, you want to all the things that you want to say that you think is important about your background and the history that you have, right? So on the right-hand side, all the questions that you want to ask, what's a day in the life like? What's your favorite thing about working here? Why are you currently hiring for this position, right? Like, so on the right-hand side, questions you want to ask. On the left-hand side, it is the questions or the things that you want to make sure you don't forget about. Can you do open source intelligence gathering on the company? Yes, I highly recommend you do open source intelligence gathering on the company that's getting ready to interview you. I do not recommend that you do a lot of open source intelligence gathering on the person who's going to do the actual interview because you might like make it creepy, like super creepy. Like, so I see you every day on Strava. You like going for a run around 4:30 in the afternoon. You run around the lake. That looks beautiful when I looked at it through the street view. Okay. All right. I think that's it. That was the last minute. What's the biggest mistake for us students trying to get internships you recommend to change or not do? The thing about internships is it's an internship. The main thing, oh, here's the thing about internships is students, right? If you're a student right now, you have the superpower. It's gonna be the last thing I show you today. I'll try to answer questions if I can. But here's here is the superpower that students have, including you, who's currently like learning to become a thing. Like if you put CISO in here and you put people, all right, like Keith Busby, I have no idea who this is, but he's a CISO, and his messages, right? Like you could send a message or you can go to more and hit connect. Students have this ability to reach out to anybody, and I do mean anybody. So a student can reach out to anyone and say, "Hi, Keith, my name is, and I'm a student at, and I want to get into cybersecurity. Would it be possible to talk to you for 10 to 15 minutes about how you got to where you are in your career and what advice you would have for someone like me?" Every person, and I do mean every person in the whole world, when a student reaches out and asks humbly for advice on how to get to where they are in their career, internally they go, "Oh, you're so cute. You're so adorable." I remember when I was like that so many years ago. Oh my gosh. Ah, it's just so precious. Look at them. Just they don't even know what they're doing. They're just scrambling and stumbling in the dark. Of course. Of course. Let's go ahead and put a 10 to 15 minute call in the books. I'll reach out to you. Now, they may not write back immediately. They might be busy. So you hit them up in 7 days and like, "Hey, I just wanted to reach out one more time, Keith, and see if I could get on your calendar for a 10 to 15 minute phone call to see how you got to where you are in your career and what advice would you have for like someone like me." And maybe they respond, maybe they don't. But here's what you do. You do it 100 times. You really do. You just go through every single CISO here. You go through every single senior leader in cybersecurity. You go through every single one of them. You send a message and you're like, "Hey, I'm humbly asking for advice of how you got to where you are in your career. And what advice would you have for someone like me?" And I guarantee you, one of them will respond back. And that person, when you have the conversation with them, what you do during that conversation is you listen and you let them know what your main two takeaways were from the conversation that you had. And then you follow up with this before the conversation's over. Would it be okay to reach out to you in 3 to 6 months and let you know how I've been able to use the advice you've given me today? Every single one of them goes, "Oh, look at you. You're trying so hard, and I am so proud of you." Absolutely. 3 to 6 months. Feel free to follow up. That would be amazing. Let's do it. And then you follow up in 3 to 6 months. And with that, I think that's it for today. If you have questions, I'll try to get to them into the Discord chat. If not, then I'll see you tomorrow and we could potentially talk about your questions tomorrow. I don't know if this was a great crash course in the last 30 minutes on how you can improve your career over the next 30 years, but I gave you every piece of information that I had as quickly as I could without ruining it. All right, go talk. Go talk at an event. Go to your local B-sides, volunteer, go find your local crew, and go make friends. Go make friends. All right? Yeah. All right, Yuri, kill it.